Hello and welcome to this third tutorial, although you can just start here. If you haven't seen my other previous two tutorials, you can start here. I'm just going to start with this basic scene, and basically we're going to do some stuff from scripts. What I'm interested in is maybe at runtime you want to load materials or change material types, colors and things like that, or create objects without dragging and dropping them in the scene, in the editor. How can you do that in script? So that's what I want to show you today. And I've got a loose plan which I'm going to stick to, and I'm going to put on a timer for 30 minutes, so I don't have to race against the clock, but I will know at least if it's been 3 days and I've been talking, I'll know to stop. Right, so first thing, what should we do? What I want to do is, my basic idea is that I want there to be a sphere or something. So I've made a sphere on my map somewhere on this terrain. Let's put him over there, and if we get close to this ball, then maybe the ball will change our color. That's what I want to happen. So that's going to happen in script. We're going to see, are we close to this sphere? If we are, then if we're too close, like within, I don't know, 3 meters or something like that, 3 units, then we want to change the material color. And actually, we're not just going to change the color. I'm going to show you this time how to load a material. Right, I put it underneath. What am I doing? I put it underneath the floor. There we go. And we'll probably make this quadruple the size so that I can spot it. And I've already got some materials. Let's add that one. Okay, so we've got our sphere somewhere on the map, and if we get close to this, let's make the sphere go a different color and do it all by the script. So what you want to do first of all, in your assets folder, create another folder called resources, capital R. Okay, and it's from that folder that we're going to load in the script materials. So in your resources folder, let's make a new material by right-clicking anywhere in the folders, like body. Go to create material, and we want this to be very different from blue. I'm going to call it my warning mat, like that. And so we want a nice warning color, maybe red. Red's a bit too scary. Let's go yellow. Yellow's not as scary. Nice Mikado color. Right. So we've got our warning map material. So now we need a script that will ask if our player object gets within 3 meters of that, then change the material of our sphere. So I'm going to right click in my assets folder and create our script, and we'll call this what should we call this? I don't know, like too close. We'll call it too close. If you get too close, I'm going to change yellow. Right. I'm going to double click on that script to bring up my editor, which is VS Code, isn't it? Yes. I always call it the wrong thing. Right. So first of all, who are we going to attach this script to? We need to attach it to probably our sphere, and let's call that our close detector. I'm not very good at names in this tutorial, it looks. So that's our close detector, and we want to put the too close script onto you. Okay. Always attach your script before writing the script, else you'll forget about attaching it. Right. So firstly, we want to know what object we're detecting. So let's call that, let's make a variable called, it's going to be a GameObject, and it's going to be, I don't know, like a target. We'll call it target, therefore. GameObject target. Now, we're going to do everything in the script, so we're going to say, I want you to assign target to, and we're going to find We could do object tag, object of type, things like this. We're just going to go find, just find, and that will look for a game object. And we've called our player, just to prove that. There he is, player. So it's going to find that object. If we put in terrain or camera or directional light, it would find those objects. Okay. Actually, interestingly, if we did this with the camera, because the camera will follow around our player, we could detect if the camera's close enough. And we'll do that later, I think. Do it with camera, find of type. This is just a note for me, so I can show you how to find objects of type, which might be useful. Right, so we found our target, who is the player. So now, in update loop, we want to ask, is the target close enough? Or too close? Close enough, that'll do. Right. So we're going to ask a question, if target, now we need to use a vector 3 really. We need to say something like, if distance, if the distance is greater than 3 meters, sorry, less than 3 meters, less or equal to 3 units, then go and change material. Okay, so that's what we're going to ask. So we definitely need a function, so void called ChangeMaterial. There we go, and that will change the close detector's material to yellow. But first we need to do this calculation. So we need to find distance. So distance is going to be measured in a floating number. So float distance equals, I'm just going to put this on a new line so it fits on the screen. You don't have to put it on a new line. Float distance, and then we're going to use a built-in vector 3 function called distance. And what that takes is two vector 3, so two positions, can you see me? Two positions, and then it will measure the distance between them. Brilliant, that's exactly what we want, so that I don't have to do any vector maths. Right, so distance. So we want the target's transforms position. That's our first vector 3. So that's the position of our target. And then we want the position of the sphere itself. Now, this script is attached to this game object, so we can write this dot transform dot position. There we go. So what transform are we talking about? We're talking about the transform of the object that this script is attached to. In fact, you don't have to write this. If you just write transform, Unity will know that you're talking about the script, sorry, the object that the script is attached to. So this dot is default. I'm just going to leave in this dot so that's clear for everybody what's going on. So distance is a distance between the sphere detector thing and our target is the player. So if the distance is less than 3 units, change material. At the moment, change material does nothing. So we want to load the correct material. So to do that, we're going to get hold of our material component. So we want to say GameObject, which gives us this function, get component. Something looks wrong there. Get component. We want to get hold of the mesh renderer. That's the component that has our material. Dot. Just going on to a new line again so everyone can see. Material equals, and we're going to now write resources dot load, and then in here we need the name of our material, which was it warning mat? I think it was warning mat, like that. I'm just going to go and check that. So what we're trying to load is from resources. Yeah, this material. So we want this to go yellow, and it is called warning mat. Okay, brilliant. I actually remembered something. Then we've got to tell the load function what type of thing we're trying to load. So we write type of, and then in brackets we want a material, capital N, because it's a type, and then finally, where are we? Finally here, as a material. There we go. Don't know why this is red. Is it because I've written GameObject wrong? Something like that. I don't know. Right, I'll sort this out in a moment. So, we want to tell the load that the warning mat is a material, and we want to return it as a material so that we can assign the present material in the mesh renderer this type. Right, I'm just going to save this, try and run. We're not quite finished. I just want to know what I've done. An object reference is required. Do I have to? No, wait a minute. If I just write GameObject, sorry, get component, it knows that it's talking about. Oh, was it this? Do I have to write this dot GameObject dot? Ah, that's right. Okay, so that's what I should have written. This dot GameObject get component. So that's talking about our close detectors GameObject, or the GameObject called close detector, as a GameObject, and then get its component mesh renderer, which is this. And at the moment, our material is bioluminescence in here. So our function now will load the other material and use that. Okay. So the one thing that we've got to add then is, what if the distance is greater than 3 meters? So else, then we want to reset the material. It would be better for me to write another function like this. That would be nice and tidy, but I'm not a good programmer, so I'm just going to write it in here. So I'm just going to copy this. There we go. And just write the name of our original material. Now, some of you will be banging your heads against something, hopefully something soft. Be careful, because this is probably the worst way to do this, but I'm just doing it to show you how to load materials and things like that at runtime. So don't worry, I haven't gone crazy. Right. What would be really nice is we just pass in the name of the material that we want to load. That would be much better. I'm going to do that. If this works, I'll go and do that. Okay, so let's run it. I'm quite excited. Okay, it's running at least. It's compiled, or has it? So no problems yet. So our first thing is we've got to go and find that sphere. And then get near it. Right, I'm just going to ride up a little higher. Oh, there he is. Oh, now I've got to wait and drop. Please don't glitch through the terrain. Oh, okay. Probably very impressed with my driving skills. Right, I thought I was within 3 meters there, and we haven't changed colour. Oh, there we go. There we go. We're very, very close. Lovely. Okay, so first thing we want to do is change how close we need to be. So we want maybe, I don't know, 12 meters away. Lovely. So everything was working. It was changing back to the correct color. Let's just refactor this code so it's a bit better. Basically, we want to put in here ChangeMaterial. We want to say, if we're less than 2 meters, what is it called? Warning mat. Warning mat. And here we just want to say ChangeMaterial biolum, like that. that looks so much tidier and more sophisticated. So here, in our ChangeMaterial function, we want to take the parameter, take the argument, which is going to be a string, and we'll call it mat name. There we go, that's nice and clear. And so here, we just need to write mat name, and then whatever material string name we pass in, we'll load up the corresponding material. Right, let's just go and see if that works. Hopefully my driving will be a bit better this time, and I'll be able to go close to the thingy, the close detector, more quickly. Oh, there he is. Right. And he's turned yellow. Brilliant stuff. Brilliant stuff. Yes. Brilliant. Right. I'm just going to close the door. Oh. Sorry about that interlude. Right. So what we want to do now. So what have I done? I've talked about this. Haven't done that. I've loaded material. Oh yeah. Right. Let's say that our target, which has been our player, is now our camera instead. There we go. Do it with the camera. So target is not going to be the player, it's going to be the camera. And it shouldn't make much difference because the camera is a child object of our player, which just means the camera it's fixed to, just follows around our player. So this time we're going to write find object of type, and that's a camera, and that's all we have to do. It doesn't know what that is. We need to write GameObject, I think. Just put that. Oh, and it's doubled it up on 2 lines. Still showing red. I think that's fine. Cannot convert type Unity engine camera to a GameObject. Oh, wait a minute. Yes. Right. Camera. Right. Dot GameObject. Can I just write? Yes. Okay. So our target variable is a GameObject. So we need to put a GameObject into it. We need to assign it a GameObject. If I'm just finding object of type camera, it's going to return that type, i.e. a camera, which is not a GameObject. So we have to get the GameObject that's connected to the target. If target was transform, we could put .transform, or if it was rigid body, we'd put .rigid body. That's how to get that. Right, so hopefully, if we just run this again, a similar thing should happen, but it's just our camera now that is the target. Just to prove to you that you can find objects in the script in different ways. Oh yeah. Yes, there we go. So a user, a player, would think that it's the object in front of me that is causing this change, but in fact it's the camera. Okay, right, so we've loaded a proper, we haven't just changed the colour, we've actually loaded a material from the script. Right, so now what we want to happen is, I want to be able to maybe attach a script, add a script to an object from the script itself. So we're not actually creating a script and then dragging it in the inspector, in the editor. We're going to do it all in script. So first let's make a little script for ourselves. And what it's going to do, I think, we want this to like explode a load of things above our close detector. So if we get close to it, maybe after 3 seconds, we want some objects to spawn above it. So we'll call it fireworks. There we go, fireworks. yeah, so let's take out update. So really, it wants a function called, let's call it go, 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 go. And we want to, let's say, create, let's say, int I equals 0. Let's say, I don't know, 101 objects. So I've created a for loop that will loop around 101 times. So let's go for create primitive. So we're going to say GameObject dot create primitive, and we'll create spheres, I think. Primitive type dot sphere. Lovely. Right, so we'd create a load of spheres. Let's just see. There seems to be a mistake here. What have I done already? Oh, I've just forgotten a bracket somewhere. Oh, right. Yep. We need one here, and now another one here. There we go. Is that right? No. Create primitive type. No, that's fine. There we go. Sorry. I love a bit of live debugging. Right. Okay. So we're creating a sphere. We need to position it above whatever this script is going to be attached to. We're going to attach it to the warning detector, or the close detector, whatever it was called. So we need to position it there. So first we need to get hold of the sphere, and there's going to be 101 of them with a temporary variable. So it is a game object, and we'll call it bubble equals. So when we create the primitive, the little sphere, we're going to store it in this temporary variable called bubble. I call it temporary variable because we're making it inside the for loop. As soon as this for loop ends, it's going to be destroyed automatically for us. We can't use this variable anywhere else. It only has this local scope. If it had global scope, we could use it anywhere. And that's when you create variables up at the top here. They would have global scope. They could be used in any function. So we've got our bubble. So now we can grab hold of bubble, get your transform, get your position, and we're going to say equals this dot transforms position plus. So imagine it's now in the very center of our what do I call it? Close detector. That's where we've positioned it, this little bubble, because we've said the bubble's transforms position equals this transform position, and this means this the object that this will be attached to, i.e. the close detector. So we want to move them up now. So we're going to say plus vector 3 dot up times, how far do we want to go up? Well, it depends on how big the warning detector is. If it was really massive and we only moved it up a little bit, then that wouldn't suffice. And also if it's really small and we moved it up loads, that wouldn't suffice. And later on we might change the size of it. So to be a bit more sophisticated, a bit more dynamic in our coding here, we're going to refer to how big that object is. So we go to this dot transform dot local scale. You could go for lossy scale. Local scale. Go into a new line so you can see. Dot, and really we're talking about, it doesn't matter which axis we're talking about because it's a sphere, but I'll just talk about the y-axis. There we go. Right, so that number will, at the moment, if I click on our close detector, so its scale in the y is 4, so we'll go 4 meters up. Right, okay. Then maybe we could then put it in, give it a bit of a random position, because all 101 of these bubbles are now going to be just a little bit above our warning detector. So we want to add a bit of randomness to this. So we're going to get hold of it again. We could do this in the same equation, but for easy's sake, we're going to say bubble.transform.position plus equals. So that means this position plus something else, plus equals. And now I'm going to use a function of vector 3 called, no, it's not of vector 3, it's just of random dot inside unit sphere. Oh, and we need to tell it how big the sphere is going to be. So I don't know. Again, we'll refer to the scale of the warning detector, the close detector. So first of all, we're positioning a bubble just above the warning detector, and then we're saying inside unit sphere just means pick a random position within an imaginary sphere, and we don't really want it if we and we're timesing it by how big the sphere the warning detector, close detector thing was originally. Okay, well that's the plan anyway. Right. Okay, I think that would just about work. It would be nice to actually make those little bubbles pink. So let's do that. Bubble dot get component. We have to write get component here, not just refer to the transform, because the transform will be attached to every game object, but a mesh renderer won't. So Unity has built in access to the transform, but it hasn't built it into the other components. So get component mesh renderer dot material dot color, American spelling, no U in there, equals, and I'm going to make a new color, and it's going to be called pink. So we want lots of red, no green, and lots of blue. There we go. So we did this in the first of these tutorials, changing materials colors. Okay, lovely. So we create our bubble, we move it above the detector, like the spawner if you will, we then put it into like a random position, and then we change its color. So they're all going to kind of stick in the air. They haven't got rigid bodies yet. Should we add a rigid body? Now, no, let's not add a rigid body. They'll just stick in the air. That'll look kind of cool. Right, so this fireworks script hasn't been attached to anything. We haven't attached to the close detector, but it needs to. So we're going to do that. Just let's go to our too close script. So it's going to do the job for us. So we're going to add the firework script to this object. Right, so to do that, we're going to write this dot GameObject, add a component, and then you write the name of the script, which was fireworks, which is pretty cool. We've made that script and we can use it in our favorite triangle things here, fireworks. So that actually adds a script to this object, and this object, remember, is the close detector. Right. So now we've got everything in place except for calling this function. Let's just see if it works first of all. So let's say if we're within the 12 meters, let's call firework. So now firework isn't a part of this script, so we have to refer to another script. So this dot get component fireworks, and now we should be able to write the name go 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 go, because that's the name of the function we want to run, and it will spit out 101 babies. Whoa. That noise is truly terrible. If you're wearing like earphones, I'm really sorry. Right, so it knows I'll only be another, I don't know how long, but I know it's been half an hour. Right, save. Let's just go and run it now. There's a problem. We shouldn't be able to run. Right. So fireworks.go is inaccessible due to its protection level. What does that mean? Well, that means we can't just call any old function. So we're trying to call a function on the fireworks script that's attached to this game object called go. We can't call it because it's not a public function. It's not publicly available to other scripts. So to make it public, we just write public here. And you would do the same if you wanted a public variable. So if we wanted a variable to change, we could do, from another script, we could do the same thing. Right, so now let's save the script. And now I'm genuinely not anticipating any errors, any bugs. We should be able to run. Okay, everything's compiled. We've done that. Okay, so can we, from the toClose script, access another script and call a function on that other script, namely fireworks? Firstly, the fireworks script should be attached. Whoa! Okay, it's like kind of grown hair. Brilliant. So it's worked. So first thing to acknowledge that I was inarticulately saying, we've managed to put a script onto that object just through the script itself. Right, and I'll stop there. Oh yeah, every time we get too close, it's going to add loads. Right. Yeah, so in toClose, first thing that we do is add the fireworks script. If we didn't add that, it wouldn't work. Okay, because we wouldn't be able to call fireworks go because the script hasn't been attached to the object. So the only thing that I haven't ticked off is setting a parent from script, which is fairly easy. What should I do? I don't know. I'm gonna end the video there. Right. If there's anything that you're wondering about how to do via the script, maybe scripts talking to other scripts, things like that, let me know in the comments, and I'll do a video on it. Right. Thank you very much for watching. See you next time.